Let's continue looking at our multiple choice questions here in our Chapter 3 test review. Question 14 says, given the following graphs of f and f prime, what is the value of f inverse prime of 5? So here on this question, we are looking for f inverse prime of 5. And I'm going to change that to, instead of using that f inverse notation, I'm going to use g to represent the inverse function of f. So really what we're looking for here is g prime of 5. Now remember, my rule says that the derivative is going to be equal to 1 over f prime of g of x, which means I don't want f prime at 5. I want f prime at whatever coordinate corresponds to 5 on the graph of g. Now if g, on g, if we have a point with an x coordinate of 5 that has some y coordinate which we don't know, if f is the inverse of that, that means that the y coordinate is going to be 5 and the x coordinate is what we don't know. So now let's go over to our graph. So what I'm looking for here on the graph of f of x is where the y coordinate is 5. And I can see that happens at this point right here, which corresponds to an x coordinate of 2. So that means on g we have the point 5,2, and on f we have the point 2,5, which we're looking at here. So in order to get my derivative, I need to find 1 over f prime of 2. Because if I want the derivative of g at 5, I need to find the derivative of f at 2, at the other coordinate. And so to find that value, I'm going to go to my f prime graph. And again, we are looking here at 2. And if I go up to the f prime graph, that corresponds to that point right there, which is 3. And so f prime of 2 is 3. And my derivative is 1 over 3, corresponding to answer choice C. Now starting here with question number 15, we are able to use our calculators. On question 15, it says suppose f is a differentiable function and consider the following table of function values. So in this table, we've got some values given to us for f at different x values surrounding 1. And the question says, based on these values, what is likely to be the best approximation to f prime of 1? Now whenever we're asked a question about a derivative and the only information that we have is a table, the only thing that you can do is find slope. Derivative means slope, and if I've got a table of values, all I can do is find slope. None of my derivative rules are going to work here. I'm just going to find slope. So I need to do, and I'm going to choose the 2 points that are closest to 1, which is the value that I'm interested in. And so, of course, that's going to be 1, because that is the value. And then 1.001 would be the next closest point. And so to do this, we're really going to use our average rate of change formula, f of 1.001 minus f of 1 over 1.001 minus 1. And so this would be negative 2.805 minus negative 2.800 over 1.001 minus 1. And you do have a calculator for this question. If you type all of that in, you're going to get answer choice D, negative 5. All right, next question. Number 16, consider the position function s of t equal to, let's go back, s of t equal to all of this. An oscillator moving along a line for t between 0 and 2 pi, which of the following statements is true? And then if I look at my answer choices, I notice that these are asking me questions about velocity being positive or negative. So if I have my position function, the way that I find velocity is by taking a derivative. And since this is a calculator question, we're going to do the derivative on the calculator. I want to look at the derivative over an interval of time, and so the best place to do that is going to be on our graph page. So in your calculator, you can type this into your graph page to look like this. I've got a screenshot here of the calculator. This ddx part, I did it again. This ddx part, that comes from the button that's right next to the 9 on your calculator. You can find that there among the templates. And then we just typed in our function, and the calculator graphs the function for us. And so looking at this graph and looking at our answer choices, let's see if we can find an answer. Our first choice says that the velocity of the particle is positive from 0 to 3 pi over 2. Well, if we look here at our graph starting at 0, all of this right here, this graph is negative. And so answer A is not the correct choice. Answer B says the velocity is positive from 0 to pi. Again, not true because our velocity is obviously negative here. Answer choice C says the velocity is negative from 0 to 3 pi over 2. That is true. And then it goes positive after that, and that happens to be the case here in this graph. And so let me get back up to our question. Answer choice C is going to be the correct choice. All right, question 17. At how many points of the curve y to the 4th minus 3x cubed equals 2 is there a vertical tangent line? So vertical tangent line, hopefully, good grief, I keep forgetting to get a pen for my tool, and then when I touch it to write, it changes slides. Here we go. How many points is there a vertical tangent line? So vertical tangent line, hopefully you recognize that from our flashcards, and that means that the derivative is undefined. That's what we're looking for here, wherever the derivative is undefined. And so since I'm looking for an undefined derivative, I should probably find the derivative first. So I'm just rewriting my curve here. The derivative of y to the 4th would be 4y cubed dy dx minus the derivative of 3x cubed would be 9x squared equal to the derivative of 2, which is 0. And so we're going to solve for dy dx. So 4y cubed dy dx equals 9x squared. And dy dx is equal to 9x squared over 4y cubed. Okay, so there's our derivative. And I want to know when this derivative is undefined. And since it is a rational expression, I know that rational expressions are undefined whenever the denominator is equal to 0. So I'm going to take that denominator, 4y cubed, and let's go up here. 4y cubed equal to 0. That is only true when y equals 0. And so it seems like 1 should be our answer based on that. But before we choose that, we need to plug this back into our curve and see how many points on the curve have a y-coordinate of 0. Because it could be more than 1. Because this is not a function. It's an implicitly defined relationship. So I'm going to plug 0 back in for y. And I get 0 to the 4th minus 3x cubed is equal to 2. And so negative 3x cubed equals 2. And if I divide by negative 3, then x cubed is equal to 2 divided by negative 3. And we're going to cube root both sides. X equals the cube root of 2 over negative 3. And that is only going to have, that is only one number. If it happened to be x squared, and we took the square root of both sides, then we would have to consider positive and negative. But in this case, since it's a cube root, it's not going to be positive or negative. My only answer is going to be negative. And so there is only one point where we have a vertical tangent line, and that gives us answer B.